Greetings, ITM352 students, and welcome to your very first course screencast. Today we're going to be going over the basics of web pages and web servers, how they talk to each other, how they exchange information. The objectives of this module are for you to learn the basics of HTML, the hypertext markup language. That's the language that sits behind every web page you've ever seen. And we'll also talk about CSS, cascading style sheets. Style sheets are the things that make web pages look interesting. They control every aspect of the look of web pages, the fonts, the background colors, the images, thicknesses of borders, and all kinds of visual aspects, and much more as well. And we'll get into that as well. And we're going to talk about how web pages actually work, what it is that happens when you click on a link or type in a URL in a browser, and somehow magically this thing appears, this web page appears on your browser. And we're going to really dig into the mechanics of that so that it becomes much clearer for you. So you're going to learn as a result of going through this module how to build a web page from scratch, not with a page builder, not with a website like Wix, which is point and click, but actually from scratch, down and dirty, the nitty-gritty. You're going to use web page development tools, and these are the tools that professional developers use. And we're going to be using, for this screencast, the Chrome Web Developer tools. There's a bunch of tools that hopefully you've installed by now, like Visual Studio Code, and we'll talk about some features of that. And we'll start to scratch the surface, not so much in this module, but in subsequent modules with things like frameworks and libraries, and what are the limitations of website builders and web development tools, what are the advantages of them. But in this lecture, we're going to set our sights a little bit more modestly. We're going to introduce HTML, we're going to introduce CSS, and we're going to see some very simple examples of how you can create that, add that into a file using VS Code. We're going to look at testing the web pages that we create. When we're creating a web page, we're creating a specification of something that we hope will look and act the way we want, but of course we need to test that. And so we're going to see how we can do that with a local HTTP server, a server that runs on your very own computer. And as mentioned, we'll look at the Chrome developer tools. And on your own, you're going to need to do quite a bit of work, but it's all straightforward. So when I say quite a bit, it's not trivial, but it's certainly doable. It's certainly achievable. You just have to take it a step at a time. Be very careful, follow the instructions very carefully, very precisely, and you will have success. You won't have a problem. One of the things that I always like to say about computers is computers don't assume, and you can't assume either. You have to be very explicit. Think of talking to a child, right? A child that's 2 or 3 years old and really doesn't know anything about anything, and you just can't assume shared knowledge and shared assumptions with that child. You have to tell the child everything in very explicit detail, what to do and what not to do. And that's the way you have to think about your interactions with computers when you're developing web pages, when you're developing software, is take nothing for granted. Computers will do faithfully exactly what you tell them to do, nothing more and nothing less. And if you tell them to do the wrong thing, they will faithfully do the wrong thing at your behest. So something that, it's a mindset that you need to get into, that you need to be extremely clear, unambiguous in the instructions that you give to a computer, for anything to work. So you're going to need to go through some tutorials that will teach you the ins and outs of HTML and CSS, and learn about web fonts and Chrome developer tools. I'm going to assume that you've already installed VS Code, Visual Studio Code, and Node.js. These are the foundation for everything that we're going to be doing this semester. If you haven't got those working, pause this screencast right now, go and get those installed, follow the instructions, follow the links on the course website, and you will do fine. In addition, we're going to look at the developer tools using the Chrome browser, but other browsers will work equally well. You can use Safari, you can use Firefox. The details of how they work will be slightly different, but they all offer largely the same kinds of developer tools. Okay, let's dive right in. What is a web page? Well, intuitively, we all know what a web page is. We've all been using them and interacting with them for years. But what is a web page from the perspective of the computer, from the perspective of the creator? Well, a web page is a text document. It's all text. So that's the first thing to remember. All those pictures and colors, all the things that make web pages look beautiful, the interactivity, that's all specified in text. A web page is a text document. That text document is requested by a browser, and a browser requests that document from a server. So if you type in CNN.com, that's the name of a server. If you type in ESPN.com, that's the name of a server. Facebook.com, that's the name of a server. And then you might ask for a specific page on that server, and the server will respond by sending the document that you have requested. It will send the document back to your browser. The request originated from your browser. It's served by the server, and the server will send that request back to your browser. And then, because that request is text, your browser has to figure out how to process, how to instantiate that document, how to render that document so that it looks the way you want it to look. So the browser will figure out how to do that based on the document type, the type of document that you've requested, and also on some browser configurations. So a browser may be configured in ways that will change the way that it renders the request. The server at this point is out of the picture. It does not manipulate the document. It doesn't manipulate the browser. Once it sends that document to the browser, it's hands off. And the actual display and interaction with that page is handled entirely by the browser. So this is a good thing. It means that we can store documents on servers. We can store all kinds of useful information on servers within databases, within file systems. And we can have a kind of separation of concerns where servers are really concerned with serving data and browsers are concerned with rendering that data and interacting with the user. So this is a good thing for developers. You don't have to worry about everything all at once. You worry about one thing at a time. So a browser and a server communicate in this special language called HTTP, the Hypertext Transfer Protocol. And while we don't need to become experts, there are certainly some aspects of HTTP that we're going to have to become familiar with as we work our way through this class. So let's see a picture of this. So you've got your favorite browser, and you type in a URL, www.unicorn.com/rainbow.html. So let's break this down. First of all, we see that this request is HTTPS. That means it's the secure version of HTTP, the secure version of the hypertext transfer protocol. www.unicorn.com is the address or the name of a server. That name is translated into an IP address, so it'll be translated into 72.30.21.16 or some address like that, kind of like a phone number has an area code and an exchange and possibly an extension. So you've got the protocol, you've got the name of the server, and then you've got a path to a particular file on that server that you would like to retrieve. So you send a request. Hey, can you send me rainbow.html? You're now talking to the right server. You're talking to unicorn.com. And the server says, sure, here you go. And now there may be another request like, oh, can you send me over the images? I got the text, but there's some pictures of rainbows and unicorns that I'd like to have. Oh, okay, here you go. And so this is the typical way that we interact with web servers, is as a series of these atomic requests. You request a bit of information, you get a response. You request a bit of information, you get a response. You may have noticed this sometimes if you're loading a complex web page, is that different parts of it get populated on the page at different times. Maybe the text comes up first, and then some graphics pop up, and then some ads pop up, and then some kind of streaming data comes along. And that's because these are actually different requests, potentially coming from different servers, and your browser is making sense of it all. So a browser is going to translate a URL into an HTTP request. The URL is the thing that you type in, and the HTTP request is what you send to a server. And when the server receives it, it routes that request accordingly, according to the way that it's configured. So the simplest kind of server is simply going to return a file. You asked for foo.html, it looks for foo.html on its file system, and if it finds it, it returns it to you. But there can be other kinds of routing, more complex routing, specified in the header, and I'll explain what a header is in a moment, that can allow much more complex kinds of interaction between the browser and the server. So there can be requests to a database for some information. There can be requests to an authentication server for authentication before you can proceed. So let's think about this. There's a root directory. If you're asking for a file from a server, the server has to know where that file is, right? If I tell you, come to my house, I'm at 40, and you're going to say, well, 40 what? And I have to say, I'm at 40 King Street, right? If I didn't tell you the route, if I didn't tell you what 40 is relative to, you have no way of responding to that. So it's the same thing with a web server. The server has to know the route, kind of the reference point from which requests are going to be interpreted. And then it can, if you're asking for a file, it can respond by returning that file based on the root directory, the file path. And it will figure out the appropriate document type based on the file extension. So the web server is going to pay attention to the file extension. So the browser is the client. It requests an HTTP file from a server. This is called a pull or a GET request. And the server responds with a file. So let's take a break from all these words and let's look at some examples. Okay, so I've brought up VS Code and I've created a new repository. If you don't know what I mean by I've created a new repository, you need to go back and you need to read the the advanced readings on GitHub. So I've created a GitHub repository. I've called it ITM352_F20. And now I'm going to create my first file. And you can see here, if you hover over these icons next to the repo name, one of them is new file. You can also create a new folder. You can do some other things, but I'm going to create a new file. And I'm going to call this first.html because this is my first HTML file. And an HTML file will typically begin with the HTML tag and end with the /HTML tag. But one of the things that I find really handy is you can enter an exclamation point and hit the return key, and VS Code will populate this document with a skeleton, a template. This is called Emmet completion. And now I've got the skeleton of an HTML document all done for me, saving me a lot of typing and a lot of opportunities for mistyping. So we can see that our document begins with a document type. This document type is HTML. There's the begin HTML tag and the end HTML tag. Notice that when I click on a tag in VS Code, it highlights not only the tag but the matching end tag, which is really handy. It's easy to mess those up. Within the HTML, it says that the language we're using is English. There's a head which has some meta information, like what character set we're using, and this is important for internationalization. The title of the document, my first HTML page. And then in the body, we can type whatever we want to show up on that. So we can just type text. Howdy, Earthling. Welcome to my first page. Okay, and then I can save this. Right, I can go up here and select save, or I can just hit Command S. When you're editing, you should be saving often, saving your work often. And okay, what am I going to do with this page? Well, to serve it, I need to upload it to a server. So let's go with the simple model first. I'm going to upload this to an external server. So let me bring up FileZilla. There it is. FileZilla is my preferred file transfer client, but you can there's many of them out there. You can use whichever one you like best, but I like FileZilla. And I've opened up a connection to ITM-VM, which is the server that we use a lot, and we will be using a lot this semester for testing the files that we create. So I've already got an account on ITM-VM. I have a root folder established, and I can now navigate to wherever I created the repository on my computer. In that case, it's user RN Casement documents GitHub ITM352 F20. That's where my local repository on my laptop is sitting. And you can see there's the file first.html that I just created. So I can copy that over to the server, and now I can open that page up on the server and see what it looks like. Okay, so I go to my favorite browser and I type itm352/first.html, and voila. Howdy Earthling, welcome to my first page. That's kind of boring though. Kind of boring. So what can we do to make that look a little nicer? Well, we can add some formatting. Let's say I want to make that first line bold, so I type the HTML tag that I happen to know is for bold. And now that those first two words should show up as bold. So I'm going to save that, go back to FileZilla, copy it over, say OK, go back to my browser, refresh, and voila, it's bold. Still kind of boring though. Notice that I put welcome to my first page on the line below Howdy Earthling, but it's showing up on the same line. And the reason is because, well, computers are very literal, and I have to tell it how I want to lay out the information on the page. I have to tell it when I want a new line. I have to tell it if I want things left justified or right justified or what font I want to use. So let's first enter a line break, a new line. So I'm going to save that, back to FileZilla, copy it over, overwrite, back to the browser, refresh. Okay. Whew. This is getting to be a lot of work. In fact, this is annoying, right? Every time I want to do this, I have to use FileZilla, I have to copy the file over. If I forget to do it, then I'm going to get confused. So a much better way to develop is to run a web server on your computer. And conceptually, it's exactly the same, right? If we go back to our picture, there's a client. Whoops. There's a client, there's a server. The client makes requests, the server responds to it. Nothing in this picture says that the server has to be a physically different computer. And in fact, typically when you're developing, you want the server to be on your computer just because it's easier, it's fast, it's efficient. And we'll see a whole bunch of nice reasons for doing it this way. So what you can do is, let's go back to VS Code. I'm going to assume that you've installed node.js, and you can test by typing in node dash, what you're going to have to do is you're going to have to start a new terminal window, and I've got a terminal here. And then you should get a prompt. Make sure that the terminal window opens up in the folder that you've been saving your data. In my case, it's in the ITM352_F20 folder. You can use PWD for print working directory to make sure you're in the right folder. And now I want to see if node is running. So I type node -- version, and it says I'm running version 10.16.3, which I hope is the latest version. And there's a bunch of things that we can do with node. We're going to get into those substantially as we go through the semester. But right now, I'm going to do something a little bit simpler. I'm going to run an HTTP server locally on my computer. So I just type in HTTP-server, hit enter, and it says starting up the server, serving /. Means the current working directory. Whatever folder you're in, it says that's the root. That's where I'm going to look for files. If you give me a request, I'm going to look for files in that folder. Just like if I tell you I'm at 40, I have to tell you what the street is. It's King Street. It's Punahou, right? It's something. I have to tell you what that route is so you know where to walk to find number 40. Okay, so now I can go back to my browser, and rather than specifying ITM, VM, blah, 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 I can type in localhost. And localhost is the name that we call a server when it is running on your local host, when it's running on your own computer. So I typed in localhost and it said this site can't be reached. Why is that the case? Why did it fail? Well, the default, when you enter a URL, you enter a request for a file, the default is that the request goes out to port 80. And that just goes back to the beginning of time when the World Wide Web began, and they had to choose a port number which servers would be listening to, and 80 was the default. But what we saw here is that this server is listening on port 8080. In fact, if you really want to get funky about it, you can see it's listening on 127.0.0.1, which is the convention for the local host, and 8080. It's also listening on 192.168.10.147. That's my particular IP address on my personal network, but that's not so important for now. Okay, so to find this page, I need to say localhost 8080. So I type that, and I'm getting a response from the server, but I'm not getting the page that I wanted. Why am I not getting the page that I wanted? Because I didn't ask for the page that I wanted. I just asked for the root, and it gave me the root. And now you can see these are all the files in the folder that I created in VS Code. There's this readme.md, there's a .gitignore, there's my file that I just created, first.html. If I click on that first.html, we see my boring page. Okay, but it's a really boring page. So let's look at a page that's slightly less boring to try and understand what's going on in this conversation between the browser and the server. So I'm going to open up a new tab, and I'm going to go to the ITM department homepage. And now if I want to see what's going on under the covers, right, this is what you expect to see when you request a URL. It's a nicely laid out and formatted page. What I can do is I can right-click on that page, and you see one of the options in the pop-up menu is Inspect. And if I pull up Inspect, this new window shows up, and this is an inspector. And I can look at individual parts of this page. So what do we see here? Well, it's doc type HTML. It starts with an HTML tag with language English and then a whole bunch of other stuff. And then it has a head and a body, just like our super simple brain dead page did, right? Doc type HTML, language EN, has a head, has a body. Okay? So all web pages have the same structure, the same skeleton. And then what changes is the details. Within the body, there are many individual sections, and I can look at those individually. If I hover over the various sections on the inspector on the right, I'm looking in the elements. Those elements are highlighted on the left. And this is really useful when you're putting together, when you're planning web pages, when you're debugging them, when you're trying to figure out, why am I getting the wrong color or the wrong font or something is going on. But that's only part of the web page. The other thing that we want to look at is the headers to understand what's going on when we're requesting this. So if you go up here and you see the network tab, what you can do is, once you've selected that network tab, reload the page, and you'll see a whole bunch of stuff appear on the left. And if you click on any of those elements on the left, any of those names, you will see the headers that were loaded to get that particular portion of the page. So we have about here, and that's this section of the page here. And we can see here the header. Well, this was a URL that went to shidler.hawaii.edu/ITM/about. The request method was get. The remote address was blah, blah, blah. There's a referrer policy, and so forth. So this is looking under the covers how a web page tells the server precisely what information it wants to get, bit by bit by bit. And the web page that you get is actually the accumulation of lots and lots of these little requests. So every image on the page, let's see if I can find an image, is its own request. So here's a chevron right. That's an image on the page. I'm not sure exactly which one it was, but that was its own special request. All of these little logos here, right? There's various, here's a Instagram footer, and that was its own request to get that particular logo. Okay, so hopefully you're starting to get a picture of this handshaking that's going on between the browser and the server. You understand, hopefully, that you can serve up files from your local computer or from a remote computer. If it's on the local computer, that's really handy for testing and debugging, but eventually you're going to want to transfer those files to a publicly accessible server so that they can actually be served. The final thing that you're going to need to know for today is that there's a lot of information inside HTML that is specifically for telling the browser, as I mentioned before, how to render the page, how to mark up the page. So HTML, the hypertext markup language, describes the various regions on the page and the formatting of those regions. Each of those regions, a body, a header, an area in bold, a paragraph, is an object. It's something that your browser is going to render as its own thing, its own module. And there is something called the DOM. And the DOM is, this acronym means the Domain Object Model. The DOM is a representation of everything that you see on the screen, an abstract representation. These objects, the Domain Object Model, they're objects within your domain that are modeled, and they have attributes and behaviors. So an attribute might be the font that you're using for a particular paragraph. So let's change that font. Let's go in and we'll create a new paragraph, and we're going to add a style to that. So what did I just say? That objects are things with attributes and behaviors. Attributes are things like the style of that particular visible thing on your page. In this case, the P tag is for a paragraph, and we're going to specify some attributes of that paragraph. It's going to be blue, and it's going to be in a 46 pixel font. I'm going to take the end tag of that paragraph and I'm going to put it down at the bottom. I just cut and pasted it. And now I'm going to save this. I'm going to go back to my browser. I'm going to reload. And now you see I've got blue 46 pixel on my 46 pixel fonts on my boring first web page. So how did I do that? I set a style, and that style changed one of the attributes of the domain object model, and the browser responded by rendering the page differently. So let's go back to our slides. And the final point for today is that CSS stands for cascading style sheets. This is a way of setting attributes for DOM objects. And this is completely independent of HTML, but of course it works together with HTML. So if we go back to my web page, I set a style here. These are called cascading style sheets. We're going to see other ways of setting styles as we move throughout the semester. This is probably the simplest way of setting a style. And my style consisted of two directives, two attributes, blue color and 46 pixel font. So this is a lot of information, but I encourage you to go over all the readings, install the software, and hopefully you'll be ready to hit the road on this lab for our upcoming class.